Hi guys, welcome back. We're going to look at inverse relations. Coach Aldridge asked for me to go over these so that you knew how to find an inverse. I'm going to be pretty quick right through here, and then on the back, we're just going to do the top half of the back. So hopefully this would be a pretty short one. If you're good at solving for x, then you will be awesome at this. The inverse of a relation R is written as R, the little -1. If you've taken geometry, you remember the little -1 stands for the word inverse. Like we had sine inverse, cosine inverse, that kind of thing. It says to find the inverse of a relation, you switch the x and y values, a little old switcheroo. A one-to-one relationship is a function has a 1-to-1, I'm going to be lazy right there and just spell that out, relationship if the relation, its inverse are functions. So in case you have forgotten what a function is, on a function, the domain must be different, all right? Domain must be different. So like right here, if I'm looking, your domain is your x's. So 1, 2, 3, 4. So see how all of those numbers are different. So for just a regular one, okay, that is a function. When I do the inverse, so the inverse, you do the old switcheroo. So I would have -2, 1, 4, 2, -1, 3, and -2, 4. So when I go through there and I look at my domain now, where's my problem? Okay, like right here it says, is R a function? Yes, it is. Is your inverse of R a function? No, it is not. And it is not because you have two -2's that we circled. Okay, then it says, is R 1-to-1? No. If this is no, this is no. Okay, so just keep that in mind. If you get any one of these to be no, then that one right there is going to be no. Because this right and means both of them have to be true. Okay, if your mom tells you you have to wash the dishes and pick up your room to go out with your friends and you don't do both of those, then you can't go. Even if you did one, you can't do it. So both of them have to be yes to be 1-to-1. So number 2, we would switch them. All right, let's see if it's a function. So let's look at the regular R. 1, oh, right there, the domain has 2 1s. I'm not even going to go any further, so that is a no. So guys, again, because you get a no here to be 1-to-1, it's a no. We have to have 2 Y's. 2 Y's. All right, let's look here and see if this is a function. 5, 6, -4, 9. They're all different, so yes, that one is a function. All right, number 3. All right, number 3. If it helps you to look at these points, it may. It is a function because you're not, like there's not 2 lines coming out of that first bubble. So that one is yes. If I go backwards, like this point would be 0, 6, okay? So if I rewrite that, it would be 6, 0. Right, this point right here, it was 1, 2. So if I reverse that, it would be 2, 1. Now 8 doesn't have anything coming out, and then 11 goes to 6. So if I reverse that, it would be 6, 11. So when I tell if this is a function, it is not because I have 2 6's. You didn't complete both of those, so it is not 1 to 1. It says recall the vertical line test, and y'all know what that is, to determine whether it's a relation. The horizontal test is used to determine whether the inverse is of a relation is a function. So if we look through here, this is your main one. Okay, this would be like my R. It says determine whether the relation shown represents a 1-to-1 function. So this I'm gonna put like R and then R inverse again, like we just did. So to do R, guys, you're gonna do the vertical line test. It doesn't touch more than once, so that answer is yes. When you do the R inverse, y'all don't have my sound effects and side effects. That is also, it didn't touch it more than once. So yes, this is a 1-to-1 function. When I do number 5, okay, when I do my R, I go down, it does not touch more than once. So yes, that's a function. But when I do the inverse, your inverse is horizontal lines. Y'all see how that's touching more than once in some places, sometimes 3 places. So that is no. So it is not 1-to-1. All right. We're going to flip over and try to do a few of these. I'm not gonna lie, guys, these are on my phone, okay? And my phone just said 10% on battery. So I'm going to try to at least go through like the left side or something like that. And I think y'all are smart and you will be good. But if not, just email me. The reverse of a function f of x is written as f inverse of x. It's just that little negative one, kind of like instead of the r and r prime, that's what it is. Here's your steps. Replace f of x with y. Okay, so that's step 1. Guys, I could go through here and do that on every single one of these. All right. Interchange x with y. So just switch x and y. So x equals 5y now. X equals y minus 7 now. Okay. X equals y minus 8 divided by 3 now. And I'm probably writing that way too large. Okay, that's what that means to interchange. Solve for y. So as long as from here, in case my phone goes dead or something, okay, as long as you can solve for y, you're good to go. I had put these on the bottom, okay, but we had not done composite functions yet, so just overlook those. That's my bad. I already made copies and I ain't going back. But like number 6, it says solve for y. So I would divide both sides by 5. So y equals x over 5. And then it says go back and rewrite y is f of f prime. So I mean, that's pretty simple just to go back and switch that around. But I would add 7. So y equals x plus 7. And switch that around. And maybe that, if you remember it, it might, when you take algebra 3 or whatever. Now here, I would multiply both sides by 3. Okay, so that would give me 3x equals y minus 8. And then add the 8. So y would equal 3x plus 8. And of course, switch the y out. All right. Number 9, subtract that 1. This would be x minus 1. On here, there's different things you could do. I think I'm going to multiply. Switch that around. It's still going to be negative, but 5 over 2. Multiply by the inverse of that. So I would distribute that to be plus 5 over 2. Because these right here would cancel. Those would cancel and we would distribute that. right? I'm going to flash up 10 and 11 because my thumb's about to go down, and kind of just point at it, and you can pause it, whatever. We rewrote that as y, switched them out, okay? Added the 9, and then took the square root. Okay, when you take that square root of something, you have to put the plus and minus. I'll give you a second. You can hit pause and look at it if you need to. But again, switch, solve for y. So we added 9 to both sides, so the 9 went over is where it got plus. To get y by itself when it's squared, we needed to take the square root. Number 11, rewrote that as y, switched that out. Okay, this goes back to solving the radicals that we just did. So go back and look at those notes. Add 6, cube both sides. Or take the square, the cube root. So right here, take the cube root. And then subtract that 4 to get the y by itself. All right. I know that was quick. I know that you guys can do it. Just, again, look at these steps. Okay, even if you could just do some basic, simple ones, that is better than nothing. Okay, so just keep working hard, keep trying, keep having Math Mondays. Have a great day.